Hi there, in this video I'm going to go over Exp and Logs and focus on the laws of logs. Let's just start by going over what the laws are and then look at a few examples of how we can use them to solve for x. First, we've got the multiplication law. So if two variables are multiplied, so you've got x and y, then we can separate them. And then we also have the division law, so you've got x over y. Okay, and we can separate them. In between them you've got a minus sign. Then we have the power law. So log x to the n comes down, and you've got log x base a. And as an extension of the power law, or if we apply the power law to a situation, we've got x 1 over x. This is really x to the power minus 1, and so the minus 1 comes down to the front. Similarly, x to the power of 1 over n, okay, with the nth root is really 1 over n. The 1 over n comes down to the front. So the yellow highlighted are really the same law being used in different situations. We then have the log of a base a, so when the base is the same as this number, you get 1. And log of 1, any base, is always 0. And this shows us, to these two equations, shows us relationship. They both imply each other. So y to the ax implies x equals log of y base a. So they're like inverse relationships. Now, something to add to this, it's good to know, is the change of base law. So if I've got log a base x, I can write log x divided by log of a, and then I can choose whatever base I want. So I've just chosen an arbitrary letter b. Of course, this b can be any value or any number letter that you want. Now, if we were to apply this, if we've got log a base b, log b base a, so we take log b at the top, log a at the bottom, and we were to choose a base, for argument's sake, let's just choose the base that's the same as the integer at the top. So I've chosen base b. We know log b base b gives us 1, since the log of any number to the same base gives us 1, and that gives us 1 over log a base b. So so you can see that if you take the log of a number to a certain base, you can you can flip the base of the number around just by doing 1 over log of a base b. So that's a little trick. Let's look at how we can apply this. Let's start with an easy example. So we've got, let me just get my pen out. So we've got x, 2 to x equals 10. And we're just going to take the logs for both sides. The power comes down using the power law. We've got log x log 2 equals log 10. Therefore x equals log 10 divided by log 2. And obviously you can put that in the calculator and work that out. Notice I haven't put the base, any particular base in, and so therefore by default it's base 10. Let's look at example 2. This time a bit more complicated. You might want to pause the video and have a go. So we'll take the logs of both sides. This gives us log 4. The power comes down, so we've got 2x take with 1. Log 3 equals log 4, and then it follows that we've got log 4 divided by the log of 3 equals 2x minus 1. So now I can just add the 1, and then that will give me 2x. So I can take the 2 over to the other side and get a half for my x value. Again, you can put that value in the calculator and work it out. Next, we come on to something like this. Again, we'll have to combine the logs first and then separate them out. Take everything to the other side, and so we've got x by itself. You might want to pause the video to have a go. Right, so we've got log. I'm going to use the division law here because obviously it's subtraction. So I've got x plus 4 divided by x equals 3, and I know from the two formulas which imply each other that this would therefore have to be, this would therefore imply that 2 to the power of 3 equals x plus 4 over x. Now 2 to the power of 3 is just 8, so therefore x plus 4 equals 8x, and then that will give us 8x take away x is 7x, so 4 over 7 equals x. Let's now look at this example, slightly harder. So we need to combine the logs together. Before we can use the division law, we'll need to use the power law. You might want to pause the video and have a go. So we've got log x base 5 squared take away base 5 of 3 equals the log of 5 x plus 6. Can now use the division law. So you've got log x squared over 3 equals log x plus 6, and essentially, since we've got the logs of both sides, we're saying they're equal, therefore the input values must be equal. It's the same base as base 10, and so we've got x squared over 3 equals x plus 6. Take the 3 to the other side, rearrange, we get a quadratic equation. We've got x squared take away 3x take away 18 equals 0. This can be factorized to give us x minus 6 and x plus 3 equals 0, and so therefore x equals 6 and x minus 3 is not a valid solution, since the log of a minus number doesn't exist. Okay, so this is not a valid solution, and that's fine. Okay, let me just write that down. So minus 3 doesn't exist. Right, so there you have it. Let's go to another example. Let's look at something a bit more complicated now. Now let's try and simplify this first. So we've got 3 to the power 1 plus 2x, take away 3 to the x equals 4. What we could do is write this out as 3 times 3 to the 2x, take away 3 to the x equals 4. Now we know, well, you should be able to see that something to the power of 2x, take away something to the power of x, should give rise to a quadratic. I should be able to simplify this to a quadratic. And so if we were to, let's say, y equals 3 to the x, we'll have 3, now 3 to the 2x is simply 3x, 3 to the x all squared. And we know 3 to the x is just y, so therefore we've got y squared. Take away y equals 4. And if we were to bring everything over to one side, we get a quadratic. So we've got 3y squared, take away y, take away 4 equals 0. We can now factorize the quadratic. So you've got 3y take away 4, and you've got y plus 1, and so therefore we have y equals 4 over 3, y equals minus 1. We've said that y equals 3 to the x, so we know that if we say this is 3 to the x, this is not valid. Since we can't have a value from the graph, we should know that 3 to the x will always go as a positive. And so we've got y equals 4 over 3, so let's play around with that. So we've got 4 over 3 equals 3 to the x. And if we were to take the logs of both sides, we'll get log 4 over 3 equals log 3 to the x. If we then rearrange for x, we simply get x equals log of 4 over 3 divided by the log of 3, sorry, maybe I should have written in this naturally s equals x log 3. So therefore you can divide both sides by log 3 and get x. If you put this in a calculator, you should get something like 0.262, 3 significant figures. Right, so there you have it. We've looked at a few examples of how the rules of logs can be applied.